The distributions in weights of squirrels is approximately normal with a mean of 3 pounds and standard deviation of 1.3 pounds. Use the empirical rule to answer parts A through D. Now, just real quick, remember that the empirical rule, we have the mean in the middle, and then it deals with a certain percentages in between. So you have your mean plus 1 standard deviation this way, and your mean minus a standard deviation this way, and there are 34%, right? Then you go out 13.5%, 2.35%, and 0.15 in the tails. So hopefully you have that in your head, and if you don't, you might want to go back to your notes, sketch it out, and then come back to this problem. Now in part A, we're talking about squirrels, right? 3 pounds. Well, we know that the mean is 3 pounds. 4.3 pounds. Well, if we have 3 pounds and our standard deviation is 1.3, 3 plus 1.3 is 4.3. So that means 1 standard deviation away is 4.3. Just for fun, if you'd go another one, it'd be 5.6. You go this direction, you're at 1.7, you're at 0.4. So thinking about the empirical rule, right, we know that there are 34 in these pieces, there are 13.5, and I'm not going to go any further out because I don't need to. Our problem asks between 3 and 4.3. That means we are talking about this area here shaded in orange. Because we know that area, we have it right here, our answer is approximately 34% of squirrels weigh between 3 and 4.3 pounds. Part B. What percent of squirrels weigh less than 4.3 pounds? Well, let's again kind of work on our empirical rule here. We know we have 3 in the middle. If I add 1.3 to go to the right, I'm at 4.3. The question says less than 4.3. We're talking about all of this. That's kind of a bad shade job because we got to stay under the curve. Now, the mean cuts this in half. So we know that this half, whole half, all of it that I have is 50%, right? Because it's half of the curve. And based off the empirical rule, from the mean to 1 standard deviation to the right is 34%. So if I want all of that shaded in orange, I've got half plus the extra 34. We're talking approximately 84% of squirrels weigh less than 4.3 pounds. What percent of squirrels weigh more than 3 pounds? Well, again, let's get our curve going. Man, I've got some good curves today. And the mean in the middle is 3. Well, I'm just going to stop there because it says more than 3 pounds. Well, more than 3 is all of this, right? Shaded all the way down into the tail. And we know that the mean splits this exactly in half. So this half is 50%. 50% of squirrels will weigh more than 3 pounds. And last but not least, what percent of squirrels weigh more than 5.6 pounds? Well, 5.6 is one we haven't gotten to yet. So let's go ahead and get a curve going. We've got the mean in the middle. And now as I know 5.6 is greater than that, so I'm going to add a standard deviation. So 3 plus 1.3 gives me 4.3. I'm going to add another standard deviation. So 4.3 plus 1.3 is 5.6, and now I'm there. And it says more than 5.6, so I'm looking for this orange shaded region here. Now, okay, let's think about this. Well, do I know what that percentage is off the top of my head? And you might not, right? This is 34, this one is 13.5. If I add another line, this one is 2.35, these are all percentages, by the way, and then this one over here is the tail. Because 34 plus 13.5 plus 2.35 plus 0.15 gives me the 50% that is made up on that half. So when I'm looking at my orange area, that's these two, I've got 2.35 plus 0.15, which means my answer is 2.5%. 2.5% of squirrels will weigh more than 5.6 pounds based off of the empirical rule. Now, I do want to talk about this one just slightly differently. If you have your 3 in the middle, we're at 4.3, we're at 5.6, and you want this area, well, we know that this is 50% on this half, 34 and 13.5. Those sometimes are a little bit easier to kind of come up with off the top of your head. And so if I know that I don't want 50 plus 34 plus 13.5, well, that is 97.5 is what we do not want. So 100% minus 97.5 gives me the 2.5% that I do want. So you can kind of think of it either way, whichever way is easiest in your head.